In addition to the passage of time, the single greatest factor that affects bond prices is due to changes in interest rate. So we want to take a minute to take a look at interest rate risk. Interest rate risk refers to the impact on bond prices when interest rate increases. So sometimes that's also called the price risk. The theory of interest rate risk suggests that bonds that have longer term to maturity carries a higher price risk than bonds that have shorter term to maturity. Also, bonds that have a lower coupon rate have a greater price risk than higher coupon rate. So these are two bond pricing theory, and they are called interest rate risk. What we want to do next is to take a look at a couple of examples to demonstrate in numbers that yes, indeed, bonds that have longer maturity has greater price risk, and that bonds with lower coupon also have a greater price risk. In this example, we're going to look at two bonds, and these two bonds has different maturity. So the first bond is a short-term bond. So it has 5% coupon with 10 years to maturity. Price was $796 when the yield to maturity was 8%. And the face value of the bond is $1,000. So we have all the information we need. Next, we're going to take a look at what happened to the price of this bond if interest rate goes up. So currently, the interest rate is 8%. So we're going to take a look at if interest rate goes up to 10%. So in other words, it went up by 2%. What will be the new price and also the change in the bond's price? So we have to do two things. We have to compute the new price, and we also have to compute the change in price. We'll do each one in turn. So first of all, to find the new price, we need the basic information of the bond. So here is a 5% coupon bond. So that means that the coupon payment is going to be 5% on $1,000, and that's going to be $50, but it's a semi-annual bond, so the coupon payment itself is $25. And we have a face value of $1,000. We know that this bond has 10 years to maturity. So time to maturity is 10 times 2, so the total of 20, and is our time to maturity. The new yield to maturity, so remember we're trying to find the new price. So in order to find the new price, we're going to use the new interest rate. So the new interest rate is 10% per year or 5% every 6 months. And we can compute the present value, which gives us the new price. So go ahead and compute that. You should get $688.44. Okay, great. Next, we're going to compute the percentage change in price. So anytime you're computing a percentage change, you can use the same formula. You probably have learned this long time ago. So the percentage change is equal to the new value divided by the old value minus 1. So in our case, we take the new price, which we just computed, $688.44, divided by the old price, which is $790, we're given that, which is $796.15. We subtract that by 1. That turns out to be minus 0.1353. So the price of the bond went down by 13.53% when interest rate go up by 2%. So this is an example of computing the percentage change in price or the interest rate risk when interest rate changes. Now for more practice, let's look at this same bond, but this time we assume that interest rate go down by 2%. So if interest rate goes down, we know that bond prices should go up. So pause the video and compute the new price of the bond and see what happened to the change in the price of the bond. So do the same thing again, compute the new price, so step 1, and then step 2, compute the percentage change in price. Okay, so welcome back. The information is the same, right? Everything is the same. The bond has the same coupon payment, the same face value, same time to maturity. The only difference is that now interest rate is going to go down to 6% per year. So that means interest rate is going to be 3% every 6 months. So that's really the only change. And when you compute the price of the bond, did you find that the price of the bond now, the new price, it go up? It went up from $796 to $925.61. Great. Now, we want to find the percentage change in price. So remember that the percentage change in price is the new price minus divided by the old price minus 1. So the percentage change in price is equal to the new price, which is $925.61, divided by the old price of $796.15, and subtract that by 1. We see that it is 16.26. That means it's 16.26%. So we saw that this short-term bond, it has 10 years to maturity. When price goes up by 2%, bond prices went down by 13%. So it's a minus 13.53%. When price went down by 2%, bond prices went up by 16%. Next, let's take a look at a bond that's very similar, except it is longer. So this bond has longer time to maturity. So if you look at the characteristic of the two bonds, they are almost exactly the same. Both have a 5% coupon, and the yield to maturity is 8%. The value of the bond today, the price of the bond today is the par value is $1,000. The price of the bond today is $703 for this longer term bond. So both bonds are discount bond. So we want to do the same calculation to see what happened when interest rate go up. What happened to the price of this bond? So go ahead and pause the video and compute the new price of the bond for this longer term bond and the percentage change in price. Welcome back. So did you notice that for this bond, we also have a coupon payment of $25 because it's 5% per year. On $1,000, you get paid twice per year. So $25 is your annuity coupon payment. And the face value of the bond is also $1,000. In this bond, it has 20 years to maturity. So M will be 40. And the new price, because the yield to maturity go down to 10% or go up to 10% per year. So that's 5% every 6 months. That becomes your interest. And you're computing the price of the bond today. So the new price of the bond turns out to be $571.02. Great. I hope that's what you get as well. And next, we want to compute the percentage change in price. So the percentage change in price is the new price minus the divided by the old price. So the price went down to $501.02 when it was $703.11 to begin with. We want to subtract that by 1. And that's negative 0.1879. What that means is the price of the bond dropped by 18.79% when interest rate went up by 2%. We're going to ask you to practice one more time so we will actually get all this well practiced. Now let's take a look at what happened when interest rate goes down. What happened to the price of the bond? So again, pause the video and compute the new price and also the percent change in price for this bond. Did you get $884? So it went up from $703 to $884, and that represents a price increase of 25%. So what this example demonstrates to us is in numerical terms, in numbers, very clearly, when you have a bond that is shorter in maturity, so in this case it's 10 years, the percentage change in price is smaller. So when interest rate goes up, this bond went down by 13.5%. Compared to a bond that has longer maturity, the same change in interest rate went up by 2%, the bond's price went down by 18.79%. So a longer term bond has higher interest rate risk. And you see the same phenomenon when interest rate went down. The shorter term bonds price went up, but the longer term bonds price went up by much greater percentage. So we demonstrate in a numerical example this theory that we hypothesize that bonds that have longer maturity carries a higher interest rate risk. Notice that in this example, everything about the two bonds are the same except time to maturity. We can also look at the relationship between interest rate and bond prices for these two bonds. Notice that the longer term bond has a much steeper slope. So what that means is when interest rate changes, the drop in price is going to be much greater for the longer term bond compared to the drop in price for the shorter rate bond. So the same change in interest rate results in a much smaller change in price for the shorter maturity bond. So you can see both through numbers and here through a graph that the steeper the slope represents a greater interest rate risk. So you saw it both in numbers and you all can also see it in the graph. Now let's take a look at the second hypothesis. The second hypothesis says that bonds have different coupon rate. Specifically, bonds that have lower coupon rate carries a higher interest rate risk. So to illustrate this theory, we also use two examples. We're going to have two bonds. They will be identical except at the coupon payment. So here is a low coupon bond. It has 20 years to maturity. Its current price is $802. Yield to maturity was currently 8%, and the face value is $1,000. Very similar to the problem you've done before, interest rate went up by 2%, and now it's 10% per year. Compute the new price and percentage change in price on this bond. So pause the video now and work out these two numbers. Work out what the new price is under 10% per year as your yield to maturity, and also what the percentage change in price is. Did you get the new price to be $656.82? Good job. So notice that interest rate goes up, bond prices went down, what we expect. And we can also compute a percentage change in price. So the new price divided by the old price minus 1. So we saw that the price change is a negative 18.11%. Now let's take a look at the same bond, and this time interest rate goes down instead of going up. So we'll expect the bond price to go up. So let's say interest rate went down by 2% to 6% per year. So very similar to what we have done. And once again, go ahead and compute the new price at a yield to maturity of 6%, and also compute the percentage change in price. Did you get $1,000? Now, those of you who noticed this may save the calculation for this problem, because what happened in this case is that you actually had a situation where the coupon rate is 6%, is exactly equal to the new yield to maturity of 6%. So we know that when the yield to maturity and the coupon rate is the same, the bond sells at par. When the bond sells at par, that means the price of the bond is also $1,000. And the percentage change in price, you can compute the same way. It went from $802.07 to $1,000. So it went up by 20.68%. So this is a low coupon bond. Let's take a look at what happened with a high coupon bond. So here's a bond that has a 12% coupon. Notice that everything else is the same. It also has 20 years to maturity. Face value is $1,000, and the yield to maturity is 8%. Because this bond has a higher coupon than the current yield to maturity, is selling at a premium. Let's look at what happened to the price of the bond when interest rate went up. So expect the price to go down. So a new yield to maturity of 10%. Again, please go ahead and pause the video and compute the new price and the percentage change in price. So you get plenty of practice. Welcome back. Did you get $1,171.59? Perfect. And that represents a change in price, a drop from $1,395 to $1,171. So that's a drop of 16%. Do the same calculation when interest rate went down by 2%. And let's look at what the new price and percentage change in price is. So again, pause this video and do the calculation. You should get a new price of even higher because interest rate go down. So the new price is $1,693, and it represents an increase of 21.3%. So what we have seen in here is another example of the interest rate risk theory. So it tells us that a bond that has a lower coupon, so a low coupon bond, should have a higher interest rate risk. And we show that in this example, because in this example, we see that when interest rate went up, the lower coupon bond has a higher percentage change. 18% is greater than 16%. The same when interest rate go down, again, the low coupon bond has a higher percentage change, 26%, 24.6% versus 21.3%. So we show in this numerical example that indeed bonds that has a lower coupon rate carries a higher interest rate risk. So notice in here is particularly important to use percentage change and not the dollar amount. We can also show this on a graph. It's not as obvious as the other graph because the two bonds do not cross over each other. However, if you compute the slope, you'll notice that the bond that has the lower coupon rate still have a higher slope or a steeper slope than the bond that has the high coupon rate. So in this two numerical example, we demonstrate the importance of interest rate risk. In addition to interest rate risk, there's a price risk. There's also a reinvestment rate risk. Reinvestment rate risk actually counters the price risk. The reinvestment rate risk refers to the uncertainty of when you receive your money back, at what interest rate can you reinvest those money at? So a bond that has shorter maturity actually has a higher reinvestment risk because you get your money back sooner and you have to do more reinvestment. So this is assuming that you don't have a real need for the money when the bond matures. So this is a different situation if for example, you're saving for retirement or you're saving for a down payment of a house, and the maturity day, when you get your money back, you're going to use it for real purchases. In that case, you do not have a reinvestment risk. You only have price risk, and that makes your decision a lot easier. However, if you are saving, you don't have a real need for the money, but you need to reinvest it, then you have that. You also face reinvestment risk. The same is true when you compare a lower coupon bond versus a higher coupon bond. Because for a higher coupon bond, a larger proportion of your investment is returned to you in the form of coupon. A higher coupon bond will have a higher reinvestment risk. So the price risk and reinvestment risk offset each other. For those of us who have a real need, when the maturity date and the cash has a dedicated use, then the only risk we face is price risk. In that case, it would be a good idea to buy a bond whose maturity exactly match your needs. So for example, if you're saving for retirement and you plan to retire in 20 years, you can buy a 20-year bond. And that way, when the bond matures in 20 years, you can use that money for your retirement. Or if you're buying a house in 10 years, you can do the same thing. However, if you are just saving in general, you don't know exactly when you will buy a house or exactly when you're going to retire, then you will face both the price risk and the reinvestment risk. Here's a summary of all the bond pricing theorem we have discussed so far. First of all, we established that bond prices and interest rate yield to maturity always move in opposite direction. We also show throughout multiple numerical examples that when the bond's coupon rate is equal to the yield to maturity, the price of the bond is equal to par value. In other words, the bond will sell at par. When the coupon rate is greater than the yield to maturity, so you're paying higher than the market, your bond can sell at a higher price. It'll be a premium bond. If the coupon rate is lower than the yield to maturity, you're giving a lower coupon than the market, your bond will have to sell at a discount. So the price will be less than the face value. We also showed that a longer maturity bond will have a greater price risk when interest rate changes. And a lower coupon bond will also have a greater price risk when interest rate changes. So this is all the bond pricing theory we have discussed.